So here we go, spiral 4. Let me just move this, close this. Okay, so first question is definitely a GCF question, but it's not. You're having baskets, and each basket it's going to have the same type of fruits. You're not going to have oranges and peaches on the same basket. Okay, so with that being said, you still do it this way. You can still use the ladder method. So you got 20, 28, and 42. Let's pick a number, 2. Let's say that's 10, that's 14, that's 21. Oh, and apparently that's it. Remember, this is GCF, so with GCF, even though you can continue with 10 and 14, you could do 2, and 2 goes from 10 and 14. It doesn't go into 20. And with GCF, you have to make sure all three numbers, the number that's outside here goes inside all three numbers. So that's it. Now, here's the difference. 2 does not represent the number of fruits. It represents the number of baskets. So, no, I'm sorry, it doesn't represent the number of baskets, but instead it represents the number of fruits. So this is number of fruits. This is number over here, number of baskets. Remember, every basket is going to have the same amount of fruits. Okay, so 20 is the oranges. So with the oranges, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 baskets. And how many oranges? And I'm just trying an orange here. 2 oranges, 2 oranges, 2 oranges. Okay, this is a little bit different. Okay. And then with the peaches, and let's just choose another color, peaches, you're going to have 14 baskets. Okay, I'm just moving this around. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 baskets. And each basket is going to have 2 peaches again. So you notice that every basket contains the same number of fruits and of the same time, because of the same type. We're not mixing it up. And lastly, the pears, I'm not going to draw 21, but the pears, you have 21 baskets and 2 pears in each basket, okay? It's a little bit different. You got to read the question carefully. Bus A leaves, this one was, bus A leaves every 16 minutes and bus B leaves every 54 minutes. So I wasn't aware of how big the number was going to be, but it came out to be a big number. 6 and 54. 2 times, that's 8, and here is 27, and that's it. Okay, 2 doesn't go into 8 and 27, so it just only goes 8. So this is an LCM problem. And you multiply 2 times 8 times 27, and which ends up giving you, let's see, hang on a second, if you multiply 2 times 8, 16, and 16 times 27 equals 420, that's it. 2 times 8, 16, times 27 gives you 432 minutes. So the units here is minutes. So it's 16 minutes here, 54 minutes here. If you multiply, the LCM ends up being 432 minutes. So what's 432 minutes after 2:08? If it's 2:08 now and 432 minutes have passed, what time would it be? Well, I know 1 hour is 60 minutes. Okay, so how many 60 minutes can fit into 432? So let's divide that. 432 divided by 60 minutes, or 1 hour, and 60 goes to 432. I know 7 times, because 7 times 60 is 420. And I have 12 minutes left over. So 432 is the same thing as 7 hours. And how many minutes? 12. So if it's 2:08 right now, 2 hours, 2:08, 2 plus 7, that gives me 9 hours. And then 8 minutes plus 12 minutes gives me 20. So at 9:20, so assuming this is, I don't know, it's 2:08 p.m. So at 2:08 p.m., if another 432 minutes passes, you're going to be at 9:20 p.m. So the next time that both of those buses will be at Main Street, leaving at the same time, will be at 9:20 p.m. Okay. Find the prime factorization of 480. Let me just choose 10 and 48. 10 is 2 and 5. Circle, circle, because they're both prime. 48, I'm going to pick 6 and 8. 6 is 2 and 3. Circle and circle. 8 would be twin 4, and 4 would be twin 2. Circle, circle, circle. So how many 2's are here? 1, 2, 3, 4, 5. So 2 times 2 times 2 times 2 times 2. 1, 3, and 1, 5. In exponential form, 2 to the 5th times 3 times 5. Okay? This one, we haven't seen anything like that. This is called scientific notation. Scientific notation is used to write large numbers and make it shorter. Okay, it's much easier to write something in this manner. Okay, which is a number times 10 to a certain power. Okay, and you'll learn this next year. So, anyways, the distance to the sun from Earth in meters is 1.496 times 10 to the 11. So, how much would that be in standard for? First of all, what's 10 to the 11th? So, what would be an easy way of doing this? Well, 10 to the 11th is 10 with it's 1 with 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, here, 1, 2, 3, comma, 1, 2, 3, comma. So that's million, billion. Now you got to take that and multiply it by 1.496. Okay, so you can either do that, or you can remember what we do in division. In division, let's take this number 1.496. Right. And remember what we do here. When we move the decimal, and let's just make some number up. When we move this 1 over, it means we multiply by 10, right? We move 1 over. When we move 2 over, it means we multiply by 100. When we move 3 over, it means we multiply by 1,000, right? So every time we move the decimal to the right, it means multiply by 10 or a power of 10. Okay, so in this case, this huge number here is 10 to the 11th. All right, so what we can do is take 1.496, because 10 is to the 11th power. So this, remember, every movement, every time the decimal moves 1 to the right, it's 10 to the 1st, or 10 to the 2nd, 10 to the 3rd. This is 10 to the 11th. So we're going to move this decimal 11 times to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. At 0, 0, 0, 0, 0, 0, 0, 0, and your decimal ends up there. So to clean that up, it becomes 1.496, 1, 2, 3, 4, 5, 6, 7, 8 zeros. And here is your answer in standard form without multiplying. So here you needed to apply something that we do in division. When we divide, the number outside has to be a whole number, so we move the decimals to the right. And moving the decimal to the right just means multiplying by 10 if it's 1 to the right, or by 100 if it's 2 to the right, or by 1,000 if it's 3 to the right, and so forth and so forth. So here we're multiplying this 1.496 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10 to the 11th power, okay, or 11. We're moving the decimal to 11, to the right 11 times. Okay. Use the security property. 5 times m is 5 times m, and then we're going to do plus 5 times 8. So here's your equivalent expression, 5 times m times there, plus 5 times 8, which was 40. So this is the same thing as that. Factor out. So again, we can use the ladder to find out what it's the biggest number. GCF problem. What's the biggest number that goes into 32 and 48? Let's see. Well, we can try. Let's try 2. 2 goes 32 16 times into 28, 48 24 times. We're going to use a bigger number, 4 this time. 4 going to 16 4 times. 4 going to 24 6 times. 4 times 4 is 16. 4 times 6 24. And we can go one more time, which is 2. 2 goes into 4 2. 2 goes to 6 3 times. And we're done. Our GCF is the product of all these 3 numbers. 2 times 4, which is 8. 8 times 2, which is 16. So our number outside is 16. The 2 numbers inside would be 2 and 3. Does it work? Let's see. 16 times 2 is 32. 16 times 3 on the outside is 48. So these 2 are the equivalent expressions. Okay, so I can 32 plus 48 is the same thing as 16 parentheses 2 plus 3. Moving on. Model 4 divided by 3/5. Gee, wonder where you've seen this number. So I have four things, four chocolate bars, four something. Okay, and I know they're cut into fifths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I want to do this in fifths, in 3/5. So 3/5 would be 1, 2, 3. That's 3/5. 1, 2, 3. That would be another 3/5. 1, 2, 3. Another 3/5. 1, 2, 3. So this 2 plus the 1 on top. 1, 2, 3. That's 3/5. 1, 2, 3. So I can, for sure, if I had 4 chocolate bars or pizzas and cut into 3/5, I can make 1, 2, 3, 4, 5, 6. 6 groups of 3/5. And the last one, remember, I'm making groups of 3s. I can't make a group of 3, but I can make it 2 out of the 3 that I wanted to. So here's my answer. Find the product. Times 9.6. This one has 1 decimal place. This one has 1 decimal place for a total of 2 decimal places. Let's multiply. 6 times 5 is 30. Goes 3, 12, 15. Goes 1, 43. Move a 0 here. 9 times 5 is 45. Goes 4. 18, 22 goes 2, 63, 65. Add this up. 0, 10, 6. Carry the 1, 10 again, 7. Our answer should have 2 decimal places. So 706. Okay, or it just ends up being 706. What is 4866 divided by 0.22? No idea. Let's write this out. Divided by 0.22. So again, here I'm moving the decimal once or twice, or which is the same thing as multiplying by 100. So therefore, here I'm going to move it once or 2 times. I'm sorry. Or which means multiply by 100. So my new problem becomes 22 on the outside, 4866 on the inside. Okay, and it's just now a division problem. So 22 goes into 48. Let's see, 2 times. Okay, so let me put a 2 on top. And 2 times 22 is 44. Subtract. I got 4 left over. 6 comes down. 22 goes to 46 2 times again, which is 44. Subtract, that's a 26. 22 going to 26 1 time, so that's 22. 4 left over. Let me add a decimal, Bring the 0 down. 22 goes into 40 1 time, which is 22. Hopefully you can see this. And I have 18 left over. Let's bring another 0 down. 22 goes into 180. Not. So this is not going to be 180 4 times. No, 6 times. Okay, 6 times. And that's 12. No, 8 times. I'm sorry. Yeah, it should have been 8. Sorry, 8. 8 times 2 is 16. Goes 1, 16, 17. That's 40. And something is going to repeat. So this is. I'm going to stop here, just to clean it up. It's going to be 221.18. If I go one more 0, 22 goes into 40 only 1 time. So if I round it to the nearest hundredths, that 1 does not have enough power to move that 8 to a 9. So my final answer will be 221.18. Submarine. Oh, okay. So let me do this one first. Then I'll do the submarine. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 parts. This is 1 and 1/8. 1 and 2/8. 1 and 3/8. 1 and 8. I'm sorry. 1 and 4/8, which is 1.5. 1 and 5/8. 1 and 6/8. 1 and 7/8. Okay, this is 1.75, and I know that this is 1.25. Okay. And then the other ones, you can just, if you memorize, hopefully some of you guys memorized the conversions. So 1/8 is the same thing as 0.125. So on the test, if you want 1.125 or 1.13, I did say you could round that to the nearest hundred, so that was okay. This was, you can write 1.375 or 138 if it's rounded. Okay, let me just write the non-rounded version. This is on top the rounded version, 1.13, and 1/5/8 is going to be with where is it? Here we go. 1.625 or 1.63 rounded. Okay, 7/8 is the same thing as 1.875 or 1.88. Either or. Okay, if it's rounded, 1.88. So now submarine. Okay, this one. Let's see if I can. How am I going to do that submarine? Okay, so let me see if I can use this. Submarine's all the way down at 389. So let me see if I can make this small. What happens if I make this smaller? Clear this page, okay, because I'm going to need some room for this one. Right, so I can do that. Back this, make this a little smaller. No, we can't. Hang on, sorry. No, that's not it. That's not it also. Shoot. Alright, so I guess maybe I can use my screen. Alright, so let's move this over. Forget it. Submarine is at 389, so he's all the way down here. So okay, let's make that the water. So it's all the way down here, a negative 389. And then during a training exercise, it went up 125 feet. So if it went up 389. So you're going to do 389. One way of thinking about it is to subtract 125 from that, because he's going up. 4, 6, 2. So if you subtract, if he goes up, his new level is going to be 264 negative. So that's where he is right now. So that was part one, and then he went down 225 feet, and then from here you're going to add, because you got 264, you're going to go down to 25, 9, 8, 4, 9. So now all of a sudden, so that was first, he went up 125, now he went down 225, so his new level is negative 489, okay? And then he went back 305 feet, so from now he's going to go up. So he's at 489. To go up, you're going to have to subtract from that 305. 4, 8, and 1. So where is he now? At 184 negative. Okay, so 389 where it was where he started. He went up 125 feet, so 389, 388, 387, 386, etc., all the way to 264. That would be 125. And then from there, he went down again to 225 feet. So from 264, if you count yourself and walk 225 steps, it would take you all the way to negative 489. And then if you were at negative 489 and took 305 steps up, you would end up at 184. So where is he now? At negative 184. Okay. That's it. I'm uploading this right now.